Please inform other students to join the meeting. Okay, students, in the previous class, we have discussed fourth module and we have completed fourth module by doing some problems related to Castigliano second theorem. And we have already completed average deflection methods and deflection equations. So be study well on those topics. And today we are going to study the fifth module, that is the buckling and stability and critical loading in this chapter starting. Here we need to discuss various columns, threads, everything in this module. So first part is buckling and stability, critical loading. These all are to be studied as a first class. This is the basic terms used in a column and thread that should be understood. But before that, we must know what is a thread and what is a column. There are two terms, that is one is thread and another one is column. So when we are considering a thread, a structural member subjected to axial compressive force is known as thread. Very important term. A structural member subjected to axial compressive force is known as strut. അത് ഏത് ഡയറക്ഷനിലും ആവാം, that should be horizontal, vertical or inclined. But commonly we say strut as horizontal and inclined member. Even though the strut having vertical members, but we are normally said strut as horizontal or inclined element. Just remember this thing. Strut is a structural element subjected to axial compressive load, like compressive force, and stress may be vertical, horizontal, or inclined. But we are telling horizontal and inclined structural member as strut. Normally, we won't say vertical member as strut. It's an important term. And the cross-sectional dimension of strut is very small because that will be a long one. So, considering the length to area, the cross-section will be very small. Okay. In the case of a strut, the cross-sectional area is low compared with length of the structural member. And normally, the strut can carry only small compressive loads. We cannot use strut for supporting a load of heavy compressive load. It is used only for supporting small compressive loads. And the examples of struts are roof truss, bridge truss, everything. You know that roof truss in our home or any hall, auditorium, when we are going to that, you can see an element like this. Here you can see that there will be three elements. This is inclined, and this is horizontal. Such elements are known as strut. And you must know what is a column. Then only it will complete it. When a strut is vertical, it is known as column. Now you may understand why we are telling horizontal and inclined structural member as strut, and normally we are not telling vertical structural element as strut because that is known as column. Okay, vertical strut is known as, അല്ലെങ്കിൽ vertical structural member is known as column. നമ്മൾ വീടുകളിലെല്ലാം നോക്കുകയാണെങ്കിൽ you can see pillars of our home that is pillared inside the mud surface. That is a long one. That is an example of column. In our classroom, you can see a lot of columns, and even you can see spread at the top. Okay, the cross section. It's a very important term. The cross section of a column is very large compared to straight. Comparing with the length of the vertical element, the cross section also will be very large to support compressive load. that is column. And this can carry a lot of that heavy compressive load can be carried out by the column. Can you understand? Columns are provided for supporting heavy compressive load, and the cross section area of a column is very large. And normally it is used with concrete and steel buildings. In every construction, column is very important parameter. We need to support the building on the basis of strength of column. So first of all, you must write what is strength. Then we need to write column, and you need to compare strength with column. You can compare strength with column very easily because the cross section area can be compared, because strength, the cross section area is small, column, the cross section area is large. So please write down strength. Fifth module heading is the, then you have to write the subheading as basic terms. Basic terms. First one, strength. First one, strength. Please write down in your notebook. Strength. A structural member. Please write down. A structural member. A structural member subjected to axial compressive force. A structural member subjected to axial compressive force is called strength. Is called strength. Strength may be horizontal, inclined, or vertical. Strength may be horizontal, inclined, or vertical. Comparing with the length of the strength, comparing with the length of the strength, comma, cross-sectional dimension, comparing with the length of the strength, comma, cross-sectional dimension, of strength are small. Of strength are small. Of strength are small. Normally, it can carry smaller compressive loads. Normally, it can carry smaller compressive loads. താഴെ examples എന്ന് പറഞ്ഞിട്ട് എഴുതാം. You need to write the examples. Strength used for roof truss, comma, bridge trusses. Roof truss, comma, bridge trusses. So now we will discuss what is a column. As we have already mentioned, when comparing with strength, the shape, the structural member will be in vertical direction alone, and it can carry a large number of compressive load, as well as this can be having large cross-sectional dimension. So subheading is the column. when a thread when a thread when a thread or structural member or structural member is in vertical condition is in vertical condition it is called it is called column it is called column it is called column. Comparing with length comparing with length comma cross sectional dimension of column are large. 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 The columns can carry full stop ഇട്ടിട്ട് the columns can carry columns can carry heavy compressive loads. Heavy compressive loads. Heavy compressive loads. താഴെ എക്സാമ്പിൾ ആയിട്ട് എഴുതുക. Columns are used in columns are used in columns are used in concrete and steel building. Columns are used in concrete and steel buildings. Columns are used in concrete and steel building. Columns are used in concrete and steel buildings. Now you draw these two figures. Example of strut and column. You can see that struts are normally set as horizontal element as well as inclined elements. But columns will be always in vertical condition. In this module, we are focusing mainly on this column. And for solving a column problem, we have an equation known as Euler's equation. And it is not applicable for all strut elements. So we need to derive another equation for strut as well as column that is known as Rankine theorem. So these all things are we are going to study in adjacent classes, next classes. Hope you have drawn this one. Just draw three rectangular blocks in inclined direction, horizontal direction, and vertical direction. So now you need to know what is radius of gyration. No need of further explanation. I know that you have already understood what is radius of gyration from your mechanics classroom. And whenever we are giving a term known as moment of inertia, area moment of inertia, we remembering this term again and again, that is K. And we know that moment of inertia I is equal to area A into K square. So that K is known as moment radius of gyration. It's an important term in the case of a column and strut. So I have given this as an important term, and sometimes they may ask in your question paper what is radius of gyration. The distance from a given axis at which if all small elements of lamina placed, the moment of inertia of lamina about the axis is not changed, the distance is called radius of gyration. It's a definition for radius of gyration. You need to remember this term whenever you require, not only for this subject, in upcoming subjects in MOM, dynamics of machinery, and then design of machine elements. In all subjects, the radius of gyration is an important term, and you must remember what is that. At least the equation for K, that is square root of I divided by A, where I is the moment of inertia and A is the area of section. So no need to write this one. Just remember this one, and you can write the radius of gyration K is equal to root I by A. That's enough. If you're not following the slides and you are not able to write the slides, please inform me because that's very important while we are studying. Now we need to
Already.
understand. Okay, you need to write this one, right? Is it?
Ah,
Okay, please go. The distance from the given axis at which the distance from a given axis at which the distance from the given axis at which the distance from the given axis at which if all small elements of lamina placed 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 comma the moment of inertia of the lamina 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 does not about the axis does not change 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 then the distance is known as then the distance is known as radius of gyration. അതായത് when we have an axis and a small lamina is placed at a distance from that axis and the small lamina doesn't change its moment of inertia, then the distance between lamina and the axis is known as radius of gyration. Okay, and the equation for radius of gyration is root I by A. Root I by A, or I can written as I is equal to A into K square. This is a common equation. You can understand very easily. You need to study what is the equation of moment of inertia. That is I is equal to A into K square. I is equal to A into K square, where K is the radius of gyration, where K is the radius of gyration, I is the moment of inertia, I is the moment of inertia, and A is the area of section. A is the area of section. Have you written this one? May I go to next slide?
yes, sir.
Thank you. So another term is slenderness ratio. It's an important term. Slenderness ratio denoted by lambda. Slenderness ratio denoted by lambda. Actually, it is the ratio between length and the radius of gyration. In some cases, we will take slenderness ratio as effective length of the column divided by minimum radius of gyration. But commonly, we can understand that it normally for a column member that will not be any change in k. Normally, with that can be taken as k itself. So The slenderness ratio will be lambda equal to LE by K or K minimum. There is no change. Slenderness ratio is equal to effective length of column divided by minimum radius. It's an important term. Sometimes they may ask in your question paper, define slenderness ratio. Then you have to write it is the ratio of effective length of the column to the minimum radius of gyration. And normally it is denoted by the letter lambda. And if the lambda is small, that's an important thing. What is it can be? If the lambda is small, its load carrying capacity will be less. Whenever we are planning to design a column, we have to understand what type of loading is coming there and what is the amount of load acting at the column. If the load at the column is very high, then we need to reduce slenderness ratio. We need to increase radius of gyration. Or in other words, we need to reduce the effective length of the column. This is an important term while designing a column. Just write what is slenderness ratio. If you have written, I can go to next slide. May I go to next slide?
Yes, sir.
Thank you. Whenever we are giving importance for slenderness ratio, there are different type of column. According to the length of the column, we can say it as long column, short column. Obviously, there is a medium column too. That is when we are uh, having a column with slenderness ratio greater than 50 and 80, that column is known as medium column. Okay. First of all, you need to know what is a column. Then you need to understand what is a long column, then what is a short column, and what is a medium column. In case of a long column, the cross-section dimension will be small compared with the length. Length will be very large and cross-section will be small. So when we are taking LE divided by K, that is slenderness ratio, greater than 50, sorry, greater than 50, then it is known as long column. There is also a medium column. It's normally divided as short column and long column. A small range is there. I forgotten that range. If in the case of a mild steel, slenderness ratio must be greater than 80. And cast iron, there will be very high slenderness ratio. According to material, the slenderness ratio varies and defines the long and short column. Right. Long column. Heading. Long column. Long column. When length of the column, when length of the column is more compared to its cross-section dimension, is more compared to its cross-section dimension, is more compared to its cross-section dimension, then it is called long column. Then it is called long column. Then it is called long column. Or in other words, or in other words, LE by K min greater than 50, LE divided by K min greater than 50, it is known as long column. It is known as long column. For mild steel, lambda greater than 80 is called long column. An example ആയിട്ട് എഴുതിക്കോ. For mild steel, lambda greater than 80 is called long column. Subheading എഴുതുക. ഇത് നേരെ ഓപ്പോസിറ്റ് ആണ് short column. That is, when LE divided by K min less than 50, then it is known as short column. And if the actually in the case of mild steel itself, you can see that lambda greater than 80 is taken as long column, and if the slenderness ratio is between 50 and 80 in case of mild steel, that is known as medium column. As we have application of both the terms, that is short column properties as well as long column properties will be for a medium column. And we have already mentioned that we have different type of text and columns. In such case, long columns are under Euler's theory and Rankine's theory. Everything will be in mixed condition for a medium column. You will understand when we are deriving the terms and doing some problems on respective equations. So write heading short column. When length of the column is less compared to when length of the column is short or is less compared to when length of the column is less compared to when length of the column is less compared to when length of the column is less compared to its cross-sectional dimension, its cross-section dimension, then it is called short column. Then it is called short column. LE divided by K min less than 50. LE divided LE എന്നുള്ളത് സബ് ആണ് കേട്ടോ. ഈ എഫക്റ്റീവ് ലെങ്ത് അതാണ്, ലെങ്ത് തന്നെയാണ്, സബ് ആയിട്ടാണ് ഈ വരിക. എൽ ഇ ഒരേ സൈസ് അല്ല, ദർ ഇസ് എ മിസ്റ്റേക്ക്. എൽ സഫിക്സ് ഇ. LE divided by K min less than 50. Now there are two type of loads are there in a what's a column. There are two type of column we have studied, that is long column and short column. And when we are studying that thing, we need to understand how a column breaks. Under the load of crushing, only the short column fails. Okay, it's an important term. Crushing load acting on short column fails the structural member. Or in other case, the long columns are failed due to buckling load or crippling load. Okay, you can write crushing load. Crushing load. Crushing load. The load at which the load at which the load at which short column fails by crushing is known as crushing load. Is known as crushing load. Next heading, crippling load and buckling load. Bracket le critical load nu kuda iriko. They may ask what is critical load. Crippling load, buckling load and critical load are same. Crippling load, buckling load and critical load are same. Heading of the crippling load, buckling load, bracket le critical load. The load at which the load at which the load at which long column starts buckling, the load at which long columns starts buckling. Buckling in a word bending. The loads at which long columns starts buckling, bracket bending, is called buckling load or crippling load or critical load. Buckling load, crippling load or critical load. Both these sources, that is crushing load or crippling load, is depends on following factors. We have to derive equation of Euler's as well as Rankine according to these terms. That is first one, amount of load, how much load is acting on the column, that will affect the crushing load or crippling load. In the case of short column, that is crushing load. In the case of long column, that will be crippling load. And the length of column. According to length of the column, only we can understand whether it's short or long. So length of the column is very important. And next one is end condition of the column. End condition of the column. We have 4 end conditions for a column that I will discuss in the next slide itself. And that end condition also will be very important parameter. Also cross-sectional dimension of the column, that we know that when length is very increased, that will be long column. When length is less, that will be short column. And in case the cross-sectional dimension of the column increases or decreases, that also will be an important parameter to determine whether it's a crushing load or crippling load. And another parameter is material of the column. Which material? In the previous case, we have discussed mild steel having long column, mild steel will be greater than 80. But if that is less than 80, that will not be a long column. So these parameters are very important. That is amount of load, length of the column, end condition of the column, cross-sectional dimension of the column, and material of the column. Amount of load, length of the column, end condition of the column, cross-section dimension of the column, and material of the column. അത് ഹെഡിങ് ആയിട്ട് എഴുതിക്കോ. Parameters determines crushing load and crippling load. Parameters determine crippling load and crushing load, അല്ലെങ്കിൽ crushing load and crippling load. Can I go to next slide? Please write down fastly. There are 5 parameters which determine crushing load as well as crippling load. According to these 5 parameters, we are going to derive Euler's equation and Rankine's equation. So these are very important parameters. Amount of load, length of the column, n condition of column, cross-sectional dimension of the column, and material of the column. Have you written? May I go to next slide?
Yes, sir.
Okay. And now we will discuss what is n condition and effective length. There are four n conditions. First one is both end are hinged. It is also will be mentioned as pinned. Hinging and pinning are same. In your syllabus, they have mentioned it as pinned. So both end are pinned. Second one, both end are fixed. And third one end fixed and one end hinged. And last one is one end fixed and other one is free. You can have the figure. By looking the figure only, you can say. Please draw these figures because no need to draw double line. You can draw just single line, but endpoint should be hinged. That is pinned one. In your Windows, you have pinned circuits, hinged circuits, etc. But there is another second figure. Here, effective length also marked as L is equal to LE. That is, in the previous case, that is slenderness ratio, we have a term LE. Then how that is determined is discussed here. There are four conditions, end conditions. First one is both ends are pinned. You can see that here first pinning and here also pinned. And here there is fixed end here. There is no pin here. You can compare this end and this one. You can twist this length according to your wish, but it is fixed here. But other end is free. The load is applied at a free end. In such case, the effective length will be taken as 2L. Okay, LE is equal to 2 into L. If this is the L, the effective length will be 2L. And third one is both ends are fixed. If both ends are fixed, then effective length will become 0.5 into L. Here you can see both ends are fixed. And another one is one end is hinged or pinned and other end is fixed. In such case, LE will be 0.7 L. These are the four conditions. Please draw these figures. നോ നീഡ് ഓഫ് ഡബിൾ ലൈൻ. നിങ്ങൾക്കൊരു സിംഗിൾ ലൈൻ ആയിട്ട് മാർക്ക് ചെയ്യാം കേട്ടോ. ഈ ലൈൻ ഇവിടെ വരച്ച് ഇവിടെ ഒരു ഹിഞ്ചിങ് കാണിക്കുക, ഇപ്പുറത്ത് ഒരു ഹിഞ്ചിങ് കാണിക്കുക, ഇതിന്റെ ലെങ്ത് LE ഈക്വൽ ടു L എന്ന് കാണിക്കുക. ഇവിടെയാണെങ്കിൽ ഫിക്സ്. അടിയിൽ നോർമലി നമ്മൾ ഫിക്സഡ് എൻഡ് കാണിക്കാറില്ലേ? നമ്മൾ കാൻഡിലിവർ ബീമിന്റെ എല്ലാം സൈഡിൽ ഫിക്സഡ് എൻഡ് വരക്കുന്നത് ഇതായിട്ടാണ്. എന്താ പറയുക, ഒരു ഫിക്സഡ് ആയിട്ട് കാണിക്കുന്നതാണ്. അതിന്റെ ഫ്രീ എൻഡ് ആയിട്ട് മറ്റേത് കാണിക്കുക. സിമിലർലി ഹിയർ ബോത്ത് എൻഡ്സ് ആർ ഫിക്സ്ഡ്. ഒരു ബെൻഡിങ് കാണിക്കണം എല്ലാ റോഡിനും, ബിക്കോസ് വെൻ വി ആർ അപ്ലൈയിങ് എ ലോഡ് ഡെഫിനറ്റ്ലി ദർ വിൽ ബി bending or buckling. This is known as buckling. If the column length is short, definitely that won't buckle, that will fail. I will keep this slide as such. On the time you can put your attendance in your command window. Please type your attendance in the command window. After drawing the thing, you can leave the class. Six and 14 absent.